Hi, Jeffrey. Andrew. Hello. All right. It's good to see you guys. I did reset the modem today, so I'm hoping we won't have internet issues like we did last time. Yeah, how are you guys doing? Yeah, we still have 3 minutes before people join. Thunder Daniel. Hey, welcome. Yeah, so we'll wait a few minutes, and then once we have more people, we'll start. It is the last live class, right? So I'm it's weekend after this. it'll be it'll be good. Was it a long week for you, Andrew? Yeah, yeah. This week felt a little long. It's so nice outside. I wish I can go and play. Um, yeah, this lockdown is going on for so long, isn't it? Yeah. Okay. Yeah. The internet speed, it seems, is good. It says excellent connection. It's in the green zone, so it seems to be working fine. So Thunder Daniel, you're from Boise. Andrew, where are you at? Yeah, and Jeffrey, where are you at? Oh yeah, yeah. Well, it's good to be busy, right, Andrew? And this is tough time for a lot of people. Uh, I mean, the number of unemployment that you hear is quite massive, right? Central Texas, oh my, it must be really hot now during the day, right? I almost went to live at Texas when I graduated from Caltech from with my master's degree. I actually got a job offer at ExxonMobil, and they have an office in Houston. So I flew down there. I really liked ExxonMobil. I still like the company now, and yeah, so I actually accepted the job offer, and then I was about to go work there in their planning division. I thought it would be really cool. The planning division manages billions of dollars of worth of projects. So I thought it's a small team. So I got into that team and I thought, oh, this would be so fun. And then actually came up with a business idea. So I ended up pursuing that instead of going to ExxonMobil. But I would have lived in, um, lived in Texas. So Daniel, my sister's blog is, um, what is her blog? I mean, I don't pay that much attention. Hold on. Let me search. Uh, Life is Beautiful, Sarah Tiao, and she seemed to have a lot of followers. She gets a lot of gifts from companies, like free yogurts, free like expensive bikes and expensive handmade bags and bunch of other things because these companies want my sister to write about their products in her blog and feature them on Instagram and things. Yeah, ourlifeisbeautiful.com is our blog site, and I think she does a good job. She does a good job. Yeah. Okay, Jose, hello, good to have you. Yeah, Howard Choi, welcome. Binyam, good to have you. Yeah, yeah. From Los Angeles, Angel. I used to live in Pasadena. I love living there. It's just so fun. And when I got married, the first city we lived was La Mesa, close to San Diego. So I always loved California. It's just so beautiful. You know, Taxes are high, houses are high, but other than that, the weather and the people are great. All right, let's see. Um, yeah, Binyam, you missed the class. Yeah, sorry, I set it as private for some reason. You know, my two kids appeared in the middle of the video, so I was trying to blur their faces just because I want to be sensitive and I don't want people to know how my kids look like, but I couldn't find a way. So, and I think I forgot to turn it back to public. I was gonna edit them. I'm like, do you know what? I'm gonna put it unlisted, and then I'm just gonna trust the people who are in our group that they're not gonna like share photos of my kids everywhere on the internet. My wife gets sensitive on that. Just we're trying to be careful. So anyway, yeah, don't share pictures of my kids out on the internet. I trust our group. But and that's what happened. So I set it as a private, and then I forgot to turn it back on public. So anyway, it's back up, and I think I'll probably delete it a week from now, just so that I don't leave a permanent record of that. My wife is a lot sensitive, and I just want to honor her wish. So anyway, sorry about that. Sorry that you guys couldn't watch the video. I think yesterday it went pretty good. Um, yeah. So I think you would get something out of the video for sure. All right, DC is still raining. Oh man, yeah. Okay, I'm in Washington and it's beautiful over here. Weather is just so awesome. All right, shall we get started? We have 12 people. Yeah, 12 people. That's 13 people. So not as many people. It is Friday after all, so I appreciate you guys being here on Friday. Let's spend some time, talk through some things, and today. So this is what I was thinking, guys. What I was thinking is, um, let me share. Okay. Oh yeah, yeah. Okay, yeah, that's right. Forgot that you guys can see the screen. So I was thinking, okay, originally we were gonna talk about OOP design patterns, but yesterday we kind of talked about that. So I'm gonna just highlight some of the solid principles and factory versus builder. Um, and I was thinking, okay, why don't we spend a little bit more time on system design, particularly with containerization? And Hacker Hero is a really good example because some of the features in Hacker Hero is just would have been so hard to build if we didn't have containers. So I thought, we can spend time here. But before we do any of this, the most important thing is, this being the last live class. I wanted to see if you guys have had any topics that you wanted us to discuss as a group, or if you wanted me to elaborate more on. Okay, so why don't I do this? Why don't I cover some of the OOP design patterns, um, and then I'll share some things about the data structure. And then while I'm doing this, I think that will take me about 5 to 10 minutes to cover these materials. So in that 5 to 10 minutes, why don't you guys think about, okay, is there, this being the last class, is there anything else that would benefit you in terms of, preparing for technical interviews, or getting better with system design or data structure? Okay, so we'll just cover the first thing. Yeah, and if you have questions, go ahead and post it. Let me. Okay, why don't we actually just go through the questions we have now, and then once I answer that, we can go into this. So go ahead and post questions if you have things that you're curious about. We can talk about it. So I see Thunder Daniel asks, "What are my thoughts on WordPress website?" I like WordPress. It's neat. It's written in PHP, and WordPress is very powerful. I think WordPress is great for people who don't know how to code, and they can get a WordPress site, get some plugins and do some very powerful thing. Even for those who know how to code, you can use WordPress as a content management system to manage like people's website. I think even Coding Dojo's website, I think some of it they're using WordPress to power, so that like marketers can just go and edit some of the content which would be updated on the homepage and other pages throughout Coding Dojo's website, instead of them bothering the engineer every single time, which is annoying, right? So WordPress is good. WordPress is good. Is I think it's good content management system tool. So I like it. I think it added a lot of power to the world, and it also has a good blog system as well. But people are using WordPress to create websites and many other things. It's neat. They did a really good job. Recursion's killing you. Yeah, I know. Sorry. It's tough. It's hard to debug recursion. Right? Once you get better, it gets easier, of course, as with anything else. But it is kind of hard. And then I introduced dynamic programming later on and some other things. Yeah, it's hard, but you're not the only one. Feeling through the pain of recursion. Um, yeah, it's a pain. It's a pain. And other than data structure interview prep, you probably wouldn't use recursion at work. I mean, I never used a single recursion in my web development career ever. Um, and you don't want to because recursions are usually you don't usually need it to build anything like enterprise, right? If you're creating data structures, like you're creating a new operating system from scratch or creating a new programming language, or you're yeah, then you need to use recursion because with dynamic programming you can be really smart about managing resources. But like web application, web development, you're using recursion. If I was your supervisor, I'm like, what are you thinking? You know, one logic wrong in your recursion can bring the entire server down. So I would just not want my engineers to use recursions on any of their code. But I may ask that during interviews just to see if they can break down their logic and do it. Just because a lot of people ask, and maybe I'll just ask that too, right? But I wouldn't expect my engineers to use recursions. Horrible, horrible practice, right? Okay, so let's see. Yeah, if you're bad at algorithm, just get better. You can. It's not hard. You just need to have practice, right? So if you go to Hacker Hero, start with the first module, level up, and you will get better. But the important thing is you have to get better with using the core building blocks. You can't get stuck on looking like using other people's function. That's like the most horrible thing you can do when you're leveling up. You can use other people's functions once you know how to create any functions you can think of. Right? Okay, so that's that. Docker and containers still kind of muddy. Okay, microservice. Okay, yeah. So I think Angel. We'll spend a little bit more time talking about Angel and not Angel, Docker, Docker and containers today. So I think after that it will make a little bit more sense. Steve and I actually wrote an article for my engineering team on search engine optimization. Um, Before I did web development and started coding Dojo, I also headed internet marketing for a startup, and I was in charge of SEO and PPC. All of that is really not that hard. So maybe I'll share with you, Stephen. Send me an email, mchoi at village8888, not idiots, village88.com, and I can send you that article. I just wrote a 1 to 2 page things that people need to know about SEO. Developers need to know, especially front end, so that search engines can find the sites easy. So anyway, so I wrote that. To Yeah, no. So once you get once you come to Hacker Hero, you have 35 credits to unlock the videos. That should be enough. If you're a Dojo grad, you're not gonna need to see a video answer in every single one. So what I basically told the group is 35 should be enough to do all the things, but if 35 is not enough, just email me. I'll give you some more credit for free. Okay? So don't worry about that for now. But if you have a job already and the company already has a budget for some of the continuous training, then yeah, maybe just use the company card and pay $20 a month to get access to all of it, right? But if you don't have a job yet, just email me and say, hey, Michael, I want to really get better. Can I please have more video credit? I'll be like, of course, man. I'll connect you. What does that really mean? My question cut off. Okay, hold on. How do I get my first coding job now with so many unemployed? Best tips? Good question. I think the best way, like for you guys, if you are looking for work, send me your resume. And I can tell you what you need to do to increase your chance. Depending on the resume. If I don't look at your resume, I can give you probably 50 to 100 answers on or 50 to 100 tips. Once I see your resume, I'll have 1 or 2 tips that you need exactly to increase your chance. And then my other startup is datacompass.com, which is basically a platform to help people get jobs, to get connected with companies. So anyway, send me your resume, and then I'll give you some feedback. You can sign up at datacompass.com, take some assessments, and then I can also help you get some jobs through Data Compass. We don't charge candidates, so anyway, you can look into that as well. But if you want direct feedback, I mean, you can always send an email to the Coding Dojo advisor. You can also send me an email. I think I'm probably better because I know how to code. A lot of our career advisors are good people, but they're not technical like me, and they don't have the experience I have in hiring managers. So send me an email. I can take a look, right? And that applies to all the Dojo graduates too. Just send me an email, and then I'll take a look. Later on, Data Compass. We're currently maybe 1 to 2 weeks away from having some of these modules ready. But later, when you upload a resume, you get a score back, and you get these tutorials on how to improve your resume. So that will be available. But I'm working on that. That probably will be available next week through Data Compass. So in the meantime, just send me an email. Okay, let's see. Functional. In functional programming, use it a lot. Okay, James, I can probably help. Oh, okay, yeah, go talk to James too. Yeah, do you have experience with serverless framework? I've heard of that word a lot. I probably do have experience with it, but I have to always look up whenever these names come up. What does that mean? So I look it up, and so right now I have a blank on what serverless framework is. I heard it seems to be a cool buzzword, but I don't remember on top of my head. Okay, so yeah, open source, that's a great tip, Nicandro, contributing on open source projects. But again, if I see your resume, in 10 seconds, I can tell you what is wrong with your resume. And most of the time, you get jobs based on your resume, not based on how good you are. And it's sad, but it's really true. And that problem was so frustrating to me that I wanted to crack it through my new startup. But I've had so many students who were so good, but their resumes were so crap, and they didn't come to me in time, that they just didn't get that many opportunities. I helped them, and then immediately within a week, things really changed. With the COVID-19, I think things will be more difficult because a lot of people are not hiring. But people who have wonderful resume who aren't that good of a developer, they get jobs very, very quickly. So it's kind of the sad reality of the world we live in. Resume is super, super, super important. I would say even 10 times more important than how capable you are, right? So, yeah. And in 10 seconds, I can tell you what is exactly wrong with your resume, okay? Yeah, React.js material design projects, those are good tips, Nicandro, appreciate that. Yeah, reach out to classmates, that's great advice. Yeah, okay. Yeah, correct. That's my email address, Stephen. That's right. So you can send it there. What about mock interviews? Um, what about it? If you don't mind living in, please send me your resume. Oh, the Conjure, man, I love you, man. I think that's great. Yeah, if you want to live in Mexico, go out, reach out to our fellow alumni in the Conjure, and yeah, I appreciate the offer. Yeah, so let's see. What about mock interviews, Nicandro? Was there anything specific you had in mind as you're thinking about mock interviews? I mean, and you can type, while I'm speaking. Again, there is a 10-15 second lag. But again, the best advice I have is do the best you can to prepare. I think the advanced algorithm and the system design module I have built in Hacker Hero is really gonna help you save a lot of time. All of these things are on the internet, but I think I mean, what took me 10 to 30 times the amount to learn these things, I tried to put it down in Hacker Hero so you can learn it in hours, not within weeks. So I think it's going to give you an advantage. But after all the preparations you've done, I think the most important thing is enthusiasm, and just being who you are, being enthusiastic about the opportunity, being humble, right? Talk as a human being, ask questions, interact with them. Even if the interview doesn't go well, don't be too harsh on yourself, and try to have a good attitude. It's a numbers game, right? Computer science students, I have often heard, after they graduate, they spend 6 to 9 months just on interview prep. That's all they do for 6 to 9 months. They don't even do any interviews. And after they've done 6 to 9 months of interview prep, then they apply for jobs, and it's a 6 month game, right? They expect that after they've done that preparation in 6 months, they hope that they can find a job, and that's CS grad who spent 4 years, learning all these things. So, it clearly speaks that there is a problem in this industry. People who spend 4 years learning that, why do they have to, separately study for months to prepare for interviews? And why is it that a lot of things that people ask during interviews oftentimes are not things that web developers need to do at real work? I've had some students come to the dojo. They said, Michael, I can get all these jobs because I know how to ace the interviews, but once I get the job, I don't know what to do. I don't know how to be successful at my job. So, and that's really true. The skills to get a job and get the interview a lot of times are not the same skill sets that you need to be successful at work. So I think that's a big challenge, and that's why there are so many different startups and potential solutions trying to crack that. My new startup is going to try to crack that too. So I'll see if I can make some segues there. But yeah, we'll see. It's a very interesting topic on this, and everyone is asking all different things, right? Everyone has different opinions about how an interview should be done, so there's not one right way to prep. um, all right. Yeah. Offer mock interview services. Yeah, I don't do it, but if you want to organize with some people in the group, and just send me a calendar invite, and I can do a mock interview. I won't charge. um, don't worry, I can just do it um, for free, just because you guys are graduates. So yeah. Yeah, I don't need $50, but I appreciate in the Conjo. You can buy me lunch next time if you are in Seattle. Okay? Um, yeah, Jeffrey, yeah, I don't know. That's a good question. I don't really know. It depends on what your goals are. So, Jeffrey, send me an email with what your goals are. Send me your resume, and then I can probably then put on the hat of the hiring manager and give you more accurate perspectives on what I think, would be better for you. Right? So it depends on your goal. Depends on your goal, right? So you can send me an email, state your goal, what you want to do in the next 5 years, next 10 years. Send me a copy of your resume, and then I can see where you want to go, where your resume says where you are, and then I can then tell you whether that step I think will bridge that gap between the current reality and the future that you want to live in, or whether it's something else. Yeah, I'm in Seattle, Bellevue, Washington. So if you're here, yeah, buy me lunch. I'll take lunch from graduates. Assuming you have a job. If you don't have a job, I'll buy you lunch. Okay. All right. So these are great questions. Great questions. I love our community. I love the fact that there is this friendship that you guys appreciate. The dojo, and you guys are doing well. Yeah. So Seattle. All right. So if you have any other questions, go ahead and plug it along. But let's just do some talking. These are good questions. So okay, so let's do this. So when I designed this Hacker Hero, remember the name is Advanced Algorithm and Data Structure. It's not actually Advanced Data Structure. I tried to make it. My goal was not to cover all these edge cases of different data structures, but to cover it enough so that you can actually understand what all these data structures mean. Because if you haven't done data structure for a while, you're not going to remember. I mean, if I haven't done binary search tree last week, can I go and just do binary search tree from scratch in minutes? No, right? I have to brush it up. So this is, I designed it to be a way so that it's a very quick way for you to get brushed up on what a singly linked list, some of the most important function, queues and stacks, double linked list, binary search tree, hash table. Now, for each of these, I would consider these to be kind of the foundational. Once you get the foundational, you may get trick questions, such as how would you use doubly linked list, or how would you, I mean, there's so many trick questions like, oh, if there's a circular linked list, blah, 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 how would you use one data structure to create another data structure? All trick questions. I don't care about those trick questions that much, because if you understand the foundational aspect, I think a lot of the trick questions you will know how to navigate, right? So the goal wasn't to cover some of these trick questions, is to cover the foundation of each data structure. Now, having said that, I did add quite a bit, and the site seems to have some bugs. Like I have to reload the page. But anyway, I added just today this tab here, design patterns. So let me open that up. But also, some of you wanted to learn about graph, heaps, and what else? So anyway, I think, over the weekend, I'm going to spend some time to see if I can add, graphs, heaps, and some of the other data structures here. Now, you can imagine I can go on and on and on and list all the different data structures, but it would take too long. And I think you don't need to know every single data structure. No one does. So, I think covering the foundational is good enough. Okay. Now, over on this one, design pattern, um, I just listed some links about solid principles and factory design pattern versus builder design pattern. Now, I could spend today talking about it. I think, you will get more just by reading it when you are done with these data structures. But, just to kind of give you a nutshell, and I didn't write any of these, there were wonderful resources out there and tons of crappy resources that I had to sort through and kind of, complain like, why in the world did they write this way? That's just super confusing. So these 5 articles are the ones I'm like, whoa, they did a really good job writing this down. So anyway, solid principle, there are 5 principles that some people have thought of when it came to creating classes. So single responsibility principle, saying, hey, when you create a class, like, you should be able to explain in a single sentence what that class does, right? It should only have one job, right? If you're explaining, oh, that class employee is to do X, Y, and Z, then you're breaking the single responsibility principle. It can't be and or. It needs to just do one thing only, right? Keep the class small. Open close principle. This is where it says, hey, open for extension, not modification. What does that mean? These are concepts you really have to sit down and kind of really digest. It's not an easy concept if you haven't been exposed to these design patterns, which is why I'm hesitant really going in depth now. If you sit down and read these articles, it will start sinking in. They give some good examples, and each of the article gives different sets of examples. So I think that kind of helps you see how these works. Liskov substitution principle. Subclass must be substitutable for a superclass. You will see some examples. For example, if you have a function, and depending on the subclass type, if you have a bunch of if statement, you're doing something wrong. You're breaking this principle. So this basically says, hey, why don't you have each of the subclass also have a same method, or there's another way to do it. So there's that. Interface segregation principle. This is a little bit harder to explain, so I will just kind of leave it for you guys to understand. It's basically decoupling, and yeah, don't worry too much about some of these things. So there are 5 principles. Based on some of your comments, it seems like a lot of you were asked questions about solid principles. So my goal is, if you read this, you will be like, oh, okay, S stands for single responsibility. I stands for blah, blah, blah. I don't even remember when I read a bunch of articles. Even when I went to school, I hated memorizing a bunch of formulas. I mean, if you understand the principles, why do I have to remember the names of these opinion, right? Because all of these are just opinions of people about OOP. It's not fundamental truth. It's just opinions, right? So anyway, I always disliked memorizing, and because my brain has already enough things to worry about. Why do I have to store with all these buzzwords and things, right? So anyway, that's personal. My personal thing. I just like to understand the principles. I don't like to memorize anything, even like names of those, even like names of frameworks. Like who cares what you name that framework, right? I can create a framework too and name it whatever I want, right? So anyway, I think the world we live in just has too much information that we don't need to remember. So I think I just I resist on remembering some of these key buzzwords. Right? Okay. Yeah, Seattle. Yeah, you have relatives in Seattle. Come visit me, Stephen, and then we can hang out. Okay, cool. So I have this. So if you were to go through interview and get questions asked about solid principles, you won't be like, huh? What's solid? Liquid, gas, right? But you can have some conversation, right? If they ask you questions about factory design pattern builder, all again, like who called it factory design pattern? Why? I don't know why they named it factory design. It doesn't make sense to me why they named it builder design pattern. Like, come on, like what? If you read the thing, you will understand what it means. But I just dislike people giving bunch of names. Just like when would I actually use it just okay. I'll kind of stop. Okay, let's see. So what else? So yeah, know that I'm gonna try to add heaps and graphs, but I added some of the OP design patterns here, so you guys just read it, and I think that will be good enough. Okay, let me stop there. Do you guys have any questions? Any comments about what I talked about? Okay, I'll just wait a little bit because again there is a little bit of lag. Okay, I don't think you guys have questions. Seems like you guys are okay. All right, so let's then talk about Hacker Hero. Let's do system design for Hacker Hero. So I'm going to stop. I'm going to give you guys some time to think about how you would architect Hacker Hero, this site that you're seeing. All right. So why don't you guys, over the next 15 minutes, think about if you were in my engineering team and I say, hey, I want you to be the engineering lead for Hacker Hero. Here is the wireframe. Here's the design. I want you to build it. You tell me what programming language you're going to use, what frameworks you're going to use, if you're going to use any front-end framework, if so, what you're going to use and why, what microservices you're going to have, right? Are you going to be using containers? If so, why? Versus a traditional, server. If there are going to be multiple microservices, what you're going to use to manage those different, microservices, and so forth. Okay, so go in and think about that. And after you guys had some time to think about it, especially paying attention to what apps or services or microservices you would create, let's then take a look at how I would have done it and then compare. Okay, and then we'll spend a little bit more time talking about containers and so forth. All right. All right. Sounds good. Okay, so go ahead and take 15 minutes. Remember that system design guideline? Basically, my brain process on how I would architect any complex application, which is also in Hacker Hero system design. Where is it? It was in this one, system architecture for web application. You can go to this Medium article and you can look at the diagram. Remember this? We did this yesterday. if you weren't here yesterday, this is what we did. And there is a diagram that I inserted here. You can, I think there is a way you can download it, but you can also see it in full screen and follow each of the process. And let's say that, with this Hacker Hero, we can, initially build it so that it can handle just small amount of traffic, but, I have a grand vision for Hacker Hero. I want, to handle as much traffic as possible later and not have it break, right? So it's important that, and, I'm willing to put 20 engineers to work on these projects forever, right? So it's not a simple project, right? You're going to have a lot of engineers working on this project, let's say. I actually don't have 20 working on this project now, but okay, so let's just assume that you're going to have 10 engineers working on Hacker Hero and how you would design this. Okay, so use this diagram and write down your answer on a text editor somewhere, and then after you're done, right? And so basically what I want you to do is on system design here, challenge 3, I explained to you what the key features are, so go ahead and read that. And then you would answer these 6 questions. Okay. Let's just go over some of the key features. Admin can create new learning modules, put title, short description of the module, have long description for the module. Admin can create multiple challenges for each module, right? Okay, there are 2 types of learning module, forum, and where you can, there's one with subtopics like the advanced algorithm where you see, different subtopics. There is another module where you don't see multiple subtopics, you just see all one, like the, learn to code, basic algorithm. There's also a forum. Yeah, I'm getting tired. You guys read it, take some time, and then take 15 minutes to just blurt out answers to these 6 questions. Yes, Dikandra, you need to avoid people cheating. And you need to actually record every single keystroke of the user and be able to play back for me. Secure? Yeah, you can, I hope so. I hope so. Yeah, we do. Yeah. James, did you have a question? Yeah. The Hacker Hero, if he didn't use containers, some of this would have been hard. Yeah, you need to, and then let me also tell you that there is a version 2 of this where imagine Hacker Hero, there is a learn Ruby on Rails. And I click on it, I click on the challenge, and the way that it would work is it wouldn't just show the challenge here, but imagine you're going to see a server terminal that you can type, and there are the file systems here, right? So I can click on any of the files or folders and create new files, remove them, all of that. We built a lot of things from scratch. Yeah, remember if you look at the process overflow, Git flow per microservice, right? Git repository per microservice. If the application is complex, you use Git flow, where engineers are to fork the repository. There is a development branch that they work on, and then they submit that pull request to the master or the original repository. So that you do that Git flow, especially if you need versioning. If the application is not that complex, then you can just use GitHub repository. People can be collaborators for that same repository. You don't need to fork the repository. So in the flow, I actually have some links that you can read to learn more about the difference between Git and GitHub Flow. Right there on the bottom left side, there are articles you can read that explains in detail the two distinct Git flow versus GitHub flow. There's also a GitLab flow. Oh, it gets so confusing. And then there are all these other ways where people can also use Git to collaborate, but I would say use either GitHub flow or use Git flow. Yeah, so in the Git flow, no one has access to the origin other than the engineering lead. All right, everyone has to just fork, right, and submit pull request. Yeah. Okay, 15 minutes, well, 13 minutes now. Go ahead and spend some time, okay? And to help you guys to stay focused, and if you're watching this, if you're watching a recorded version of this, you shouldn't just fast forward 20 minutes or 15 minutes and see how other people do it. You won't get that much. You should just sit down, take 20 minutes, go through this process overflow, because the goal is for you to internalize some of the principles that I laid out so it becomes natural. It becomes part of your decision-making process, right? So you should do that too. All right, get to work. I'll be back in about 13 minutes. At 6:50 p.m. my time, I'm going to come back. I expect answers to what? Yeah, to the questions, those questions at Hacker Hero. Okay, good luck. I'll be back. All right, you guys still have time. Yeah, I'll be here too. So if you have any questions, put it on the chat box. I still want to give you time to go through the process. And I don't know if that's enough time, but just do the best that you can. Let's just get it started. Yeah, Angel, that's a good question. I'll elaborate more on that. We can spend some time talking about the Git flow, because then I can tie that in with the continuous integration, continuous deployment, continuous. What's the term? You guys know I hate these terms. Continuous integration. Okay, continuous. What was the term? Continuous. Okay, I know I have it in the. Oh, continuous delivery. Oh yeah, continuous delivery. Okay, whatever. Yeah, so I'll explain some of that flow. Yeah, so when the conjure, your flow reminds me of the GitHub flow. The Git flow is a little more complex. Yeah, so I think what you're describing, yeah, that's what people do with smaller projects. GitHub flow works just fine. But for some of the more complex projects, Git flow requires quite a bit more coordination. So I know what you're talking about, Angel. I'll explain more in depth. Yeah. Yeah, knowing how to use Git well, it's it's tough. I mean, it's like there's so many programming languages. You can do so many things differently using Git. So there's no really one right answer to it. But I think people have tried a lot of different ways, and now like these kind of two ways are kind of becoming like the dominant way that people are adapting. But then there is also GitLab flow where they're competing with both of these, and it's like, oh come on, it's so confusing. Good questions, James. Good. So, that's exactly the things that I was thinking too. So your head is on the right place for sure, right? How do we do it? I mean, if this was an interview, I would say, well, assume that there is no plugin. How would you build it? How would you actually build that plugin? Because then I can see how you think, right? And then, if you were one of my engineers, then I would be like, okay, before you actually go build that plugin, spend one day to investigate if there are tools or plugins we can leverage or other microservice where we can leverage so that you don't have to spend a few weeks building that plugin yourself, right? So so that's kind of the frame that you would think about in interview. I would say assume no plugin, design it for me. How would you design that? And I needed to support 20 different programming languages out there, and it would be like, oh no, I need to make it work for Python, and there are different versions of Python, different versions of Node. People want to do it in TypeScript, oh, PHP, all these different versions work differently. And I say, you need to support all of those. And you'll be like, oh my goodness, this is insane. But that was the type of problem that I had to solve when we built Hacker Hero. And you're only seeing the level 1 challenge. When it comes to, okay, now I need to be able to deploy Ruby on Rails, a Django app, all of this, and create security around so that one user can't hack into another user's account, becomes a nightmare. It does become a nightmare. This is why it took me a year and a half, guys, to build Hacker Hero. I mean, you're seeing the simple versions of it, but the level 2 editors, we haven't launched it yet, but it will probably come very soon. And we also record it. So every single keystroke that you write, every single file you create, every single server commands you run, we record it and we do a video playback. Yeah, it's massive. It's a massive project. It's one of the biggest projects I worked on. But I think that's why it's good to talk about this, because without containerization, I think building Hacker Hero would have taken 3 to 4 more times than what it did. Ask for a piece of paper? Yeah, of course. You will have a whiteboard. In an interview, guys, they don't expect you to come up with the right architecture. They want to see how you think, right? So it's a conversation, right? So even if you don't split out answers, if you're asking good questions, they had great conversation and they love that you were thinking about, whoa, okay. See, I mean, just the questions that you're asking, if they were high quality questions and you're probing, and they're seeing that, oh, I like working with this person. This person is friendly, is asking good questions. I like how this person kind of breaks down a problem. I mean, all of that is as important as spitting out the right keywords. So remember that when you do the system design interview, right? So if you're doing the whiteboard, if you need some time, ask them, can I have some time, right? But take a little bit of time to digest, but make it conversation and ask them, hey, how about this? How about that? You can even ask like, I mean, conversational. Don't freeze. That's the last thing you should do. Okay, let's see. Well, James, that's what we were thinking about doing. But we ended up not building our own interpreters. Yeah, so I told my engineers, okay, if there's not a service we can use, you guys need to build all the interpreters, right? But we found, and this was really hard to find, but we found a service that we could install. And it supported all these major programming languages already. It needed to be run on the command line, right, as a file, in a server. So we took that, we built some layers on top, and we can feed that server different commands in different programming languages and different versions. It would execute it on a safe virtual sandbox, and then it would spit out the result back. Yeah, but if that wasn't available, we would have built the interpreter ourselves, right? I would have built a microservice for every single programming language out there, right? That had a safe kind of virtual box around it, so that it can't, for example, if they were doing things to crawl up the folder and do some operations that I didn't want to do, have a bunch of if statement to protect that, as well as set up the file structure so that whoever is running that program doesn't have file permission to access files that they couldn't have, right? But I also didn't want them to run different commands to look up what are the different folders and files in that server too, right? Especially if there may be some sensitive data run by other people, right? So anyway, building the interpreter could have been very, very hard. Yeah, security, yeah, huge issue, right? But this is where containerization really comes in very neat, right? Yeah, key loggers. People cheat. You can detect. I needed it to detect copy and paste, all of that stuff. Okay, so time to submit your answers, guys. Submit whatever answers you have to Hacker Hero. So go to hackerhero.com. What was it? It was the third design challenge. And it's okay. You can delete your own response later and then edit it. So here, challenge 3, Hacker Hero. Go ahead and submit your comments, your answers to these 6 questions. And if you're not able to complete, that's fine. I know I didn't give you that much time. Still list some of the answers now in the next 2 minutes. Yeah, think about it. Hacker Hero is really a good example for you guys to see the power of containerization and the difference between containers versus traditional web servers or virtual machine. Security. There's a huge security gain that you get, especially for the things that I was building in Hacker Hero using containerization. Imgor? What is that? Yeah, I don't know what that is. Okay. Okay, go ahead and post your answer. Did you? Oh, okay, I see it. Okay, good. So Jeffrey submitted. Ezra submitted. Angel submitted. Okay, keep submitting. I'm gonna wait 1 more minute. And based on your answer, I can see that there are still some gaps, guys. There is still some gap. And maybe it was my teaching, maybe it was the process, but you don't see the answer that I'm looking for. Okay, I'm reloading. I see three submissions. Come on. We have more than, well, we got 16, 17 people. Go in and submit. I want to see. It's okay. You don't have to get it right. I just want to see uh, where you guys are at right now. I'm gonna find. Let me type in what is a serverless framework too. framework. Serverless application framework. It's a free open source web framework written using Node. Oh, it's a framework name. First framework for building application on AWS Lambda, serverless computing. Serverless computing. It's like server basically just means a computer. So serverless is just a buzzword. I mean, runs on the cloud. Of course, you're running on the computer. So this is a buzzword, but I don't understand what this means. So let me read about this a little bit. Build web. Okay. All right. What are you? Okay. I have to read about this. Okay. All right. Go ahead and submit. Okay. I see more. Okay. Jeffrey wrote some things. Angel, you wrote things. Okay. Okay. Yeah, you guys do need to watch. Let's just go through some of the things. Remember, guys, that step 3, 4, and 5 is for each microservice. For each of them. If you are going to have 5 microservices, for each of them, you're going to do step 3, step 4, step 5. So some microservices, you may decide to build it using one programming language and framework. Some microservice, you may decide to leverage Amazon RDS or do it in SQL. One microservice, you may do GitHub. Another microservice, you may actually do Git Flow, right? This is a project that you do not want to have a single microservice. You don't. That will be a huge, huge, huge disaster. You can't do it. You can't build it in a single monolithic giant application. You need multiple microservices. So for each of the microservice, what language are you going to use? For each of them, what database are you going to use? For each of them, are you going to use containers or not? So the answer that I was expecting is, my proposal is we create 3 microservices. Microservice number 1. This is what I would use for the programming language, framework, front-end framework. Database, blah, blah, blah. I would use GitLab, and then I would use these to manage that microservice. Microservice number 2. Okay, I would use this programming language. I would use this, blah, blah, blah. Microservice number 3, and then so forth. Okay? How do you get them to talk to each other? How do you get a computer to talk to each other? Right? You just send, there are a few different ways. You can send an HTTP request to another server, right? To that IP address. You can also, there are some other ways. I mentioned in step 5, some of the messaging services that you can use to have one server send a message to this service. You can also create it. That would also kind of propagate that chain, send that message to another server. There's also a way that you can do it asynchronously. And I think I put some of those examples, or I wrote some article about that. But just like, how do you have the browser talk to your web server? AJAX request. You can have one server send an AJAX request, an HTTP request to another server, right? That's one way. Okay. All key features listed on there. Yeah, so each microservice would have a feature. That's correct. Yeah. That's right. Okay, so it's almost like when you think about microservice, you're going to break. You can't build this as a single app. So if you just listed one framework, all of your answers are wrong. That's not the way to build it. And I didn't do a good job, explaining this. So you cannot build this as a single service. You cannot build this as a single framework. Recipe for disaster. Recipe for disaster, right? So again, the right answer is you needed to do this in multiple microservices, and in each of them, I wanted to see those answers to the 6 questions for each microservice. Okay, think about that. Each microservice. Yeah, some of these things, you just have to do it. You just have to build it. But there is a steep learning curve. You know, learning how to use Docker took me about 2 months. To even understand what Docker is, took me about 2 weeks. Because, you know, I watch all these videos and they all talk and it's like, what are you even talking about? Like, why is this such a hot thing? It took me 2 weeks to finally understand what Docker was. And then I think it took me another few weeks to finally understand how to deploy a Docker container. And it just, you know, that's just the game, right? You know, and I think you guys have seen it after you graduated from the dojo. It's a lot harder learning, you know, how to use, you know, these new services than at the dojo. Because at the dojo, I spent a lot of time learning it, and then I broke it down so that you can learn it in hours. But okay, so let me see if there's some questions here. Yeah, it may have been the way that I messaged it too. No, number 6. Each microservice can have multiple, oh yeah. Yeah, each microservice can have multiple containers. Yeah, so I can see, maybe number 6, I have to reword that a little bit. Okay, I think maybe I just say for, yeah, okay, so I'll reword that, but you guys still need to kind of have that mindset, okay? So Hacker Hero, let's look at this. How do we design this? Okay, well, there are many ways that you can do this. Yeah, Docker it could be confusing. So Hacker Hero, what do we need? Okay, let me put on the engineer hat. Hacker Hero. Okay. At the very least, you know, I would think about, okay, is there anything done in real time? I don't really need anything done in real time, right? In Hacker Hero yet. Although, if I do need anything in real time, I can build something off of Node. But right now, there is not a real-time component. So I can use whatever framework I want. Do I want to build something with Rails? Absolutely not. It takes way too much resources. I don't want to build this in Rails. So any of the framework would do. Now, do I want to build things using light framework, or do I want to build something with a heavy framework? I think something like this, I could actually build it using a light framework. But, you know, again, that's looking into, I was zooming into a specific microservice, right? So one way to look at it is kind of the web app. This is what the people see, right? This is where people go, you know, they do, I can pull login as a separate microservice as well, but I could just integrate that as well. So web app where people can log in, they can create accounts. This would have its own database, right? Let me not put the login as a separate service. I think that will be a little bit more confusing. I can later pull it out as a separate microservice later on. So I can have this be a web app. And this could be done using a light framework because again, I'm not going to have that many pages. You know, if you look at the flow, I have the home page, some of the pages, and then I have a map view over here, and then I have the challenge, right? So there are really 3 pages that I'm trying to organize. So I don't really need to have tons of controllers for handling 3 views, right? So light framework, I will probably go with the light framework. So, and it doesn't matter which one I use, Sinatra, or whether I use Flask, or, something like Pylon, or Express, it doesn't really matter. So I would have that. But then I also need another service where if I couldn't have the plugin, if I couldn't find a plugin where it can submit the code to run, right? These are and I can call it my interpreter or interpreting service. Then I would have probably built a microservice for each version of the language. So this one, I would say this one's run PHP 5, another interpreter service that handles Python, another one that handles Java, another one that handles C#, another one that handles, what are some other languages? Ruby. And, let's say, this is Python 3, this is Python 2. Right? So I would have all of that as a separate microservice, so that this one, I can set it up so that it receives an HTTP request, and it would have the code, so it would try to run it, and it would spit back the response back to this main app, right? So this is what I would do, but this is what I would consider level 1 test. Right, which is basically just write functions and stuff. I would have also need level 2 test, which is to basically create an entire new server with Django version 2.0 whatever running, where people can go and do stuff, right? So because I don't want them to create a Rails server here, that would take too much resource. So I would have a Rails server, Rails microservice. I would have a Django microservice. But remember, I need one for each version. So Django 3, Django 2, Django 1.5, 1.2. So you can imagine I would have a lot of different microservices to handle specific framework, right? So you can imagine that. And then each of this would have their own database. And each of them, imagine C# is, let's say Python 2 is the most popular language. I need to be able to scale this up and down, right? The number of servers or the number of containers I have, I need to be able to scale up and down. Now let's look at the ideal database structure for this. I would absolutely use relational database on this one. There's no reason to use MongoDB or non-relational database here, right? Absolutely no reason. It would actually make it way more complex. So if you said, non-relational, you better have a really, really, really good, really, really good reason. Sorry. Oh, yeah, you guys should have spoken out earlier. Okay, sorry about that. Yeah, thank you, Andrew. Yeah, I forgot to switch. So if you decided to use MongoDB for this one, you better have a strong reason, because I would very strongly disagree with you that MongoDB is a good use for this. Because, just admins being able to create these modules and blah, blah, blah. I need to tie in with the user records and comments and, blah, blah, blah. It's really relational. You can tweak your non-relational to make it work for what should be done in a relational database, but it will just make your life miserable, right? This relational database will do this extremely well, right? So I would use a relational database. Even if I have 1 million people, my database is not going to be that large, so I don't have to really worry about it. I can probably use MySQL or Postgres or MariaDB. All of them are the same. It doesn't matter. I will never use SQLite for this. Okay? All right. Now, I could have done this using servers, traditional servers. Okay, let's talk about the problem of that. So imagine I built a PHP 5 interpretive service, microservice. And this is a traditional server. You can imagine I have to have this computer running all the time, right? Even if there is no user. Why? Because how long does it take, guys, to launch a new instance or a new server from scratch? Even if I have the script running or some services to go and, launch a new virtual machine from scratch, how long would it take? We're talking about minutes, right? Too long. Is anyone going to be like, oh yeah, we're launching a new computer for you to run your PHP code, so please wait 5 minutes. They will all leave, right? So you got to have one running all the time. So imagine back to this diagram, you need how many computers? Maybe 50 servers running all the time, just in case. How much is that going to cost? It's going to cost a lot of money, right? And that's at least 50. If there's a lot of traffic, you need to scale up the number of servers. So I can easily pay maybe 5,000 a month, 10,000 a month, purely on the server cost when I don't really have that much traffic, right? Plus, not only does it take a while to launch these in a traditional server with the operating system, the amount of storage I can use here to store the user's code is smaller because operating system is huge, right? Not only that, imagine I was running imagine now a level 2 code, or imagine even some people put in some malicious code here to crawl up certain directory and perform some attacks, such as, oh, why don't you run a SQL database and run these commands, or why don't you go up to these log file and print what is in the log file, and then it actually returns back with with that sensitive information. There are so many security things that you would worry about, right? And once that security is compromised, right, it leaked out, for example, some of the database credential or some of the sensitive information stored, you're screwed. You're screwed, because there is not a way for you to detect that some of that information got leaked, right? You also have to do something so that if user 1 information is stored here, user 2 information is stored, user 10 information is stored here, you got to make sure that each of them have a security blanket around that's not touchable. Building that is probably going to be very difficult, but you have to, because you're not going to build. Another solution is you can build a computer for every single person, in every single user. If you do, right, then if user 1, this is a computer for user 1, okay, so they hacked into that computer. So what? It only has your information. But imagine I got 1,000 people. So you want me to create 1,000 servers for every single microservice? Now the cost goes from 5,000 a month to 5 million a month, right? So that architecture clearly doesn't work. To give an entire new server per user for every single language and for every single version and for every single framework that the user will be using. Because imagine one user goes and does it in PHP and then Java and then blah blah blah. You can say, okay, now please wait 5 minutes while we set it up. Oh, now you're doing. I mean, it's just a bad user experience. Really, really bad. So when you need to downgrade, yeah, I mean, so this one, the way that I told you, it kind of looks nasty, right? Because there are too many microservices. Luckily, we found something that someone already built. So the way that it actually works on ours is we have this web thing, right? And then we called it the program is called Isolate or something. It was built and was used by different universities as kind of teaching tool. And we're like, oh, why don't we use this? So that one, the way that it works is it already has kind of the security built in. So the level 1 code, which is basically the functional stuff, we can say, okay, use this much CPU, use this much RAM, and blah, blah, blah. Do it in this sandbox. They create a sandbox, and they spit out the results. So this kind of solved, okay? But for level 2 tests, but this isolate doesn't support us launching a whole Django instance from scratch, or launching a new Rails. So this meant that we also needed to build something for Rails, something for Django, something for Flask, something for every single major framework in the world. Especially if you wanted to build a test platform for Data Compass and see how people actually build applications in real time, right? Yeah. So that's the traditional server, a huge dilemma, okay? That's what happens because these servers are very expensive, right? So I need to host multiple users in a single server. so that it's a shared resource. But because I have to share multiple users in a single server, now there is a whole security issue that we talked about. Okay, comes containers. Launching my code as a container takes seconds. Seconds. Not minutes, not 5 to 10 minutes, seconds. Within a second or two, I got a whole new container that I can launch for that user. Because it only takes seconds, now I can also take it down in seconds too, right? So now with Hacker Hero, oh, you want to do something in Django, launch a whole new container just for that user. They can do whatever they want. Oh, you want to go and delete your own, delete on your own code? Go for it. Delete everything because you're only screwing yourself. It doesn't affect someone else's code base, right? So now we don't have to worry about security because we can take that down in seconds too, once that user is gone. Remember that, when we talked about the containers, one kind of the basic way to think about this is you don't need to have its own operating system. Now, there is this concept called an image. It gets a little bit more complex, but all that heavy load of the operating system is gone. You still need a layer on top, which is quite small. I asked my engineering lead this morning, hey, I know we don't need operating system in the containers, but we need some layers on top to kind of be the middle person. How big is that? 3 megabyte. 3 megabyte. Super nice, right? Because that layer is 3 megabyte and your code is 5 megabyte. Oh, so you're using 8 megabyte and you're dedicating certain CPU and RAM just while the user is active? How much do you think that's going to cost now? Super cheap. There is still cost, right? That's why, I do have later, I'm hoping that later people will subscribe, especially when they're doing these, because whenever people are working on level 2, for example, I'll be actually creating a new container, deploying a new container for that user, and I'm actually paying for it, right? It's not for free, right? So I need to find a way to make some amount of money so that, I'm not losing money and I can continue to, feed the system. Does that kind of make sense a little bit? Okay, time for you guys to ask me questions. If I was to do it in traditional, you can think of traditional computer, traditional server will cost 50 to, let's say, $100 per server per month. Right? So as it scales up and down, if you need 50 servers, multiply that by 50. If you need 200 servers, multiply that by 200. Containers, I haven't done the math, but it's going to be significantly lower. But it's not the fact that it's going to be significantly lower. The power is you can turn it off. And you can launch it very, very quickly. You can scale so much faster up and down compared to the traditional servers. And then also because it uses less CPU and RAM, because all the servers, a lot of that cost goes on the operating system. But because containers you're not really paying for the operating system, CPU, RAM, disk storage. It's not only is it cheaper, you can also deploy very, very quickly. Right? And also, isn't it nice that there was that sandbox that I created, right? So that, yeah, you can go ahead and delete your own code. Good job. And then once you're done, I just wipe out the container. Gone. No one got affected. I didn't have to worry about security. Yeah, so it depends on the way you architect it. The way that I described it is I'm launching a container per user, which you can certainly do. Now, if I said, that's going to be too costly, guys, I want you guys to engineer it so that it shares the resource with 10 other people, because you can share it with 10 other people. It's not like, everyone's running their code all at the same time, right? So I can say, yeah, go in and run it and still, create a sandbox within the user, folder so that they are not, they're your sharing resource. That's certainly possible too. I mean, in the software space, engineers are like God. We can do whatever we want. If you want to just use the container for for per user, we can. So in Data Compass, when we launch some of the tests, we do that. But I don't want to share. I'll just pay for it. You know, there is a 1 hour exam, so let me just launch a whole container for 1 hour and have them do it there. I don't mind because it's gonna cost 1 cent. I'll just suck up that one cent, right? So it depends on the use case, right? But at Hacker Hero, if I have 1 million people, do I, you know, solving the problem right now, like they're creating Django apps using Hacker Hero, do I want 1 million containers? I could, but if I want to shave that cost by a factor of 10, then I can say, okay, now guys, each container support up to 10 users, and done, right? All right, does that make sense? All right, go ahead and spend a little bit more time on containerization. This is the trend. Just like how virtual machine changed the industry, containerization is changing how softwares are deployed and managed, right? It's just, I mean, you kidding me, really? 3 megabytes of layer to represent the operating system that if you're using Windows, how much disk space do you think the Windows is going to occupy? Now, how much CPU do you think your operating system is going to occupy, and RAM? You don't have to worry about that. You can deploy in seconds, and there are all these services that you can use to orchestrate, so they would actually just launch a new container for you, up and down. This is really interesting, right? Okay, let's spend a little bit of time talking about Git and GitHub Flow. Okay, GitHub Flow. And again, there are many ways to do it, right? So I'm just talking about, few ways. Git Flow. So the way that Git Flow works is, imagine that you have a master repository. Okay, here you still have branches. So you may have, for example, 1.0, 1.1, 1.2. Okay, let's say this application is really complex, right? So I got 20 engineers working on it. I got 10 engineers working on 1.1. I got 10 engineers working on 1.2. Okay, so Angel, I'm now addressing your question, right? What do they do? Well, team that works on 1.1 feature together, why don't we actually fork it to a separate repo? Okay, and why don't we work together on this repo, right? So we can create, sub branches. We can merge our code here, and we can make sure that our things are working really well, and then we submit a pull request. Team that works on 1.2, for example, can also fork it again, and they create a separate repo, and they share that repo with the just people in that team, right? That they need to collaborate. Again, they can create sub branches, do the merges, and they can resolve conflict, build test cases, all of that stuff. And then once they're done, submit a pull request. Okay, who has access to this? 20 people are not given access to this. This is kind of the super engineering lead that says, oh, I'm going to review the pull request. Okay, so now let's go back to the scenario where there is a master repo. Someone forked it. They have their own repo with 5 other people. Okay, they create branches, sub branches, and then they bring the changes back. So remember in that example, let's say I had 1.0, 1.1, 1.2. So they create 1.1, A feature B, whatever. They merged it to 1.1, and they submit a pull request. Here's what I can do. I can have this set up so that it listens for the pull request, and then if there's a pull request, before the engineering lead reviews this pull request, Jenkins listens, or Git basically sends a request to a tool such as Jenkins. Jenkins gets that and actually deploys in stagings automatically. And you tell Jenkins to run test cases. And then it spits back and says, oh, that pull request you submitted, it broke 20 test cases. So engineering lead can either look at it and say, yeah, you broke it, or it's done automatically so that when you, let's say, oh yeah, we got this feature working, let's submit a pull request. You do it because everything worked on your local, so you put it. But Jenkins runs it, and spits out and says, oh, you guys didn't pass, you guys broke 20 test cases. They're like, oh shit, we broke something. So you guys go back and fix whatever, and then you submit a pull request, and it says now it didn't break any of the test cases. Good. So then engineering lead over here then takes a look. Okay, so it was deployed in staging. All the test cases were met. You also had your new test cases. I looked at your code. I like it. Accept the pull request. Automatically gets get merged to that one, right? But I do not give you access to this if I'm the engineering lead. You are not going to be collaborators at this master repo. You're going to fork it with the team that you want to work on, right? And maybe you're part member on this repo. Maybe you're a part member in the separate repo who's working on another version or another feature, right? So there are multiple repo that are forked, and then these different teams then go and submit a pull request. This is the case for each microservice. It's kind of the way that I would do it. For each microservice, this is how you would set it up. So you can imagine if I have 3 microservices, you're going to have, right, 3 microservices. You're going to have 3 separate master, and then bunch of forked versions. Okay, this is the Git flow. And the fact that I tie this in with the tool so that there is a pull request, then it automatically, there is a hook. So, it runs it on Jenkins and then does it. You can take it a step further so that if it actually ran the test cases and passed, automatically merge and deploy. That's called continuous deployment. It's a little scary, right? Your test cases better be good, but you can go that far if the test cases are good, automatically just deploy in the cloud. Okay, continuous deployment, continuous integration. But this process I'm talking about is called continuous integration because it's not like you're going to submit a pull request every few weeks. You work on a feature, okay, let's release this. Let's see. So you submit a pull request for that feature. So even a few times during the day, you're submitting a pull request and you're getting instant feedback from tools such as Jenkins, whether it broke anything off of staging. Of course, you can set up some of the Git hooks here so that whenever you commit, you can also have it trigger some test cases locally in your development environment and see if it also broke any test cases. But sometimes it may work fine in your local environment, but staging environment is a little different, so it may have broken some code. So it's nice to just submit a pull request and find out if you broke anything off of staging. All right, so I think, Windows 10 is 25 to 40 gigabyte? Oh my goodness. Compare that with the most popular version that Dockers use, which is 3 megabytes. 3 megabytes. Isn't that amazing? 3 megabytes versus 40 megabytes? And that's just the operating system, right? Sometimes you need another services on top. And how much RAM do you think that's going to use? So, it could be, my rule of thumb I would say, without really doing full research, is I think it could be 10 to 100 times cheaper to use containers. And you can launch things, again, not 30% faster. We're talking orders of magnitude faster to scale up and down, right? You don't have to wait 5 minutes for another server to be up. Seconds is up. Seconds is down, right? It makes a lot more sense, Angel? Okay, great. Yeah, so now like the virtual machine is kind of the old school. This new way, where it rips the operating system, is kind of the new way. The bad thing is, this all got introduced in the last few years, guys, and is getting adopted. Now everyone's like, oh, this is the way to go, and all these services are coming out, with Docker and containerization and all these movement. They're calling it cloud native, cloud technologies, continuous integration. All these were tools that existed years ago. Just like, sometimes people really like SQL, and then they like, oh, let's go non-relational, MongoDB, yeah, okay. And then, it dies down and everyone goes back to relational again. It's just a cycle. So don't get caught up on some of these movements. everything again boils down to fundamentals, the core building blocks, right? It's not that hard. But sometimes engineers, I mean, we get paid sometimes for how smart we are. So sometimes it triggers some behavior where I don't think it's okay. I won't go in there into that area that much. Okay, but yeah, okay. I'm glad this makes a little bit more sense. Maybe with this in mind, you can watch my system design diagram a little bit, and hopefully this will give you some tools. Now there are tools to orchestrate. One thing to remember is, let's say I have a microservice, and I have one container when there's not that much traffic, and then I can quickly have multiple containers, right? But imagine if I have a single microservice and I have hundreds of containers, I need some managers to manage containers, right? Yeah, you can basically look up Amazon, Microsoft, all these tools. You can either build a manager yourself, or you can just pay Amazon. They already built it, so they orchestrate these containers. So like Kubernetes is a tool to manage these containers. That's one way to think about it. And then imagine you got a bunch of other microservices. Now you need manager of microservices. So then there are other services, and everyone came up with their own name to manage all these microservices. And just imagine that you guys talked about how does one app talk to each other. Well, you can create another microservice for that, right? So that these three apps can go and send a message to this microservice, and then this microservice is going to send that message to someone else, right? So you can either build this yourself, or you can also rent them. Someone else already built it. You just pay them some money, and then do that. So that's how it works. At the core, everything boils down to that IKEA store analogy. The container is basically the IKEA store without the operating system burden, right? And then when you have a lot of IKEA stores, you need kind of a load balancer, right? Which is just another computer, right? With if and else statements based on traffic, right? So you can do that. And then microservice is now kind of another layer on top. Okay, now it's not like just one IKEA store. Now we got Walmart stores, and we got IKEA, we got Target stores, and we got like JCPenney stores. And now we need to manage all the different stores. There are services for that. And then you can also imagine, oh yeah, like if you're a Target, Walmart, or any other retail store, if you need to do some of these common things, like you need a credit card system or whatever, you can also buy another service. That's other services out there, Elasticsearch, Kibana, and other tools are all these tools that any of these microservices can leverage for messaging system, visualization, search, whatever, right? Actually, that's kind of a neat analogy, right? So this is the IKEA store, right? And they're IKEA stores, right? Because there are many. This is the Target stores. This is the Walmart store. There's JCPenney store. There's like Taco Bell stores. And then imagine, people are like trying to sell, oh yeah, you should use our credit cards system. Oh, you should use our payment system. Oh, you should use our delivery service, blah, blah, blah. So you can imagine in the cloud, same thing happens. Oh, you guys are a delivery service that offers value to the retail store, food store, tech store, whatever, and they have a name, right? Oh, your job is you're managing hundreds of IKEA stores. Oh, let me do that for you, and they have a name, right? There are other stores like, oh, you're managing like three different store types. Let me manage them for you all, right? So that's kind of a way to look at it. Okay, so I think we're done. We spent a lot of time. This was kind of the longest live class we've had. Give me some feedback. Let me know if that was helpful. Maybe I do need to write another article on what Docker containers are and how these work. But give me some feedback, okay? I appreciate you guys being here. I hope you had fun. Go in and, I'll still be around in the Facebook group to provide support and help. So go in and finish the advanced algorithms and data structures, put some thoughts in system design. And, right, if you want me to take a look at your resume, send me an email. I'll send you some resource and data compass tool that I'll be creating over the weekend. So I think that will be helpful. But I think one of the most important thing though is if you are doing this because you're prepping for the next interview or whatnot, share with me when there is some good news. Yeah, let me know. Oh, Michael, I went through the interview today, and some of the things that we covered in class, I found it beneficial. Whenever those things happen, don't keep it for yourself. Come and talk to me. I'm kind of feeling lonely. I mean, being an entrepreneur, a lot of times majority of my time is spent on issues and problems that customers are facing or employees are facing. So it's nice to share victories or cool stories that you guys are having, because most of my day is not spent on that, right? I mean, when I was running Coding Dojo, it's a lot of students who are not happy, instructors who are not happy, other staff members who are not happy, compliance departments who are not happy, and this majority of my time was all just spending time on unhappy people and listening, and it was hard. So I'm hoping that as you guys have some good stories and success, share them with me, because those really do make my day more bright, um, compared to dealing with, oh, Michael, you're gonna get sued on X, Y, and Z from customers or from, compliance, saying they're gonna shut down our schools because of blah blah blah, IRS, like tax, blah blah blah. Ah, it will be a fresh air to just hear from you guys and you know hear some of the success stories when you have them. Okay, so let me know when you guys are having some good moments so that I can celebrate with you. All right, so okay, I think we'll end it here. I'll stay for a few more minutes in case you have any questions, so feel free to linger. Otherwise, it was good to have you guys. Although we did it through live chat, maybe later we'll do Zoom so we can see each other. If you do come to Bellevue area, hey, send me a message. Let's go have lunch, right? Let me get to know you. Say you're in the algorithm class, right? And if you're some of the active ones, I'll remember you, right? So reach out to me. Let's have lunch and see if I can be helpful. But even if I can't be helpful, let's just go. I mean, we gotta eat, right? After the lockdown, right? After the lockdown. Okay, all right. Thank you so much, guys. Some of you, I did receive your resume. I can have a better idea what you need to do. So expect me to get back to you, let's say early next week. Okay. All right. Cool. Thank you, guys. Bye for now. Yeah, come visit. We can have group lunch. We can have group lunch for sure. It'll be fun. Yeah, thank you, Howard. Yeah, keep in touch, guys. Let me know. I gave you my email, so feel free to email me too. Email me when happy things happen, not just when you guys are going through some hard times. Okay? All right. I'll see you guys later. Thank you so much. Bye for now.